these formulas will help you to solve numericals. So we have 4 different cases here. So these are different cases here. Cases or whatever you want to call it as. Let me take the easiest. So can you tell me what is this? Guys, what is this? It's a cantilever. It's a cantilever. So what is this?
Load.
Point load. It is at a distance L. It is at a distance L. Okay. Now, where do you think this cantilever will break? Will it break at this point or will it break at this point? Left or right? Left. Okay. So, you know that if you plot bending moment diagram, then how do you plot it? So you see the forces onto this side, no forces, no distance. But if you see here, there is some force, some distance. As you go further, more and more distance, more and more distance, more and more distance. And finally, the distance into force becomes maximum. And therefore, you see that this increases linearly. This increases linearly like this. And this is the maximum bending moment. So PL is equal to M max. So that is the maximum bending moment. Okay. So instead of M max writing here, I'll write it here itself. So case for cantilever, because I'll have to go down otherwise. Then another case. Okay. Guys, you have to remember this. M max is equal to PL for cantilevers with a point load at the distance L. You just have to remember M max is equal to P into L. Okay. One more thing. The same. This is W. So this is kilonewton per meter. What is this basically? This type of thing? UDL, uniformly distributed load. This is actually spread over a length L. If you try to draw a bending moment diagram for this, I think every time you don't need to do this. Your work is to just remember this. But some people can't remember like this. You might have to run this picture in your mind. Then you'll understand M max is equal to P into L. And that is the bending moment at this point. Okay. So here, if I have to draw the bending moment diagram for this is the bending moment diagram. Okay. So here, how much is the bending moment? 0. As you go further, whole UDL can be placed at the center at some distance. Like this. As you go further, whole UDL placed at the center at some distance. Whole UDL exactly placed at the center into half distance here. So if this is W kilonewton per meter, what is the total UDL for L meters? For every meter that it is W. For L meters it is W into L. So you can say that the total UDL here can be imagined to be placed at the center. So that is equal to WL. So that is WL. It should run your mind. At what distance it is? L by 2. So you will have a parabolic curve like this, and here you will have M max is equal to WL by how much? So sorry, WL square by 2. WL into L by 2. It is actually WL square by 2. So you should remember this equation, because see what we actually studied in the previous class. May I sing for you? So you don't have to worry about this. Usually we play with this part of the equation. Okay? So they would give the stress in the, they would give the section of the beam. You'll have to calculate the maximum moment here with using this. Then you'll have to find what is this. Because everything is given. I is equal to BD by 12, Y is equal to D by 2, something like this. And this value can be got by this. And therefore, you got 3 knowns and only one unknown. You can solve for this. Why you want to solve for the stress? Because you know that stress cannot exceed a point. Suppose if it exceeds allowable limit, you know that you just saw in the internet that wood can take up to how much? 20 MPa. Okay, if it exceeds, it breaks. Steel can go up to 300 to 400, some steels up to 600 or 500 also. You know what is the maximum stress. So you can check the stress. If the stress that you got here becomes more than the stress that you found in the internet, no? Then it's going to fail. Of course, in the next semesters, you don't have to depend on the internet, because there will be a data handbook which will give you all the maximum stresses that each of the metal can bear, allowable stresses. Okay, and maybe because all these books were used around maybe 20-30 years back, given during my time, so we did not have internet. So all this data was given in a book. We used to carry this book for the examination. Now even now you can carry the book. It is the only examination where you actually literally carry all the equations, all the data to the examination. You just have to use those equations. Okay, and then, so this is about cantilever. Let us see about the point loads. So here, simply supported beam with a point load. Here you will have P at the center. These are typical cases, because usually they ask these cases in the examination. So we should not again start doing this BMD and all. Now you should remember this equation straight away, because this, if you have to solve for 100 marks, then you need to remember this. So if it is exactly at the center, so that means it is L by 2 either way. And if you try to draw a bending moment diagram, if you try to draw a bending moment diagram here, how it will look? This will look like this. So at the ends, so you know that this side it is P by 2. This side the reaction is P by 2, because the load is exactly at the center. And now if you want the bending moment, here, bending moment, no force, no distance. So it is 0. It starts with 0. As you move across here, P by 2 into some distance, P by 2 into more distance, P by 2 into still more distance, and it increases up to this point. So you can say that it starts increasing. At this point, it is P by 2 into how much? Force into distance, how much? So P by 2 into L by 2, how much it becomes? PL by 4. So PL by 4. So that means at this point, you will have the M max. So this point, you will have M max, which is actually equal to PL by 4. You need to remember this equation directly in the examination. Okay? So they would give a problem. So for that, if you have this idea, then you can directly solve the problem. So then we have one more thing. Okay, is it visible up to here? Up to here? Okay. Guys, in the same way, the previous case was UDL on a cantilever. Now it is a UDL on a simply supported beam. So this also W kilonewton for every meter. And this length is L. This length is L. Where do you think the beam would have maximum bending moment? Again at the center, obviously. So for this, if I draw the bending moment diagram, here if you see no force, no distance, and you know that this, now what is the load on each side of the support, can you say? Now what is the UDL intensity? For every meter it is W. What is the total UDL? W into L. So now what is the load taken by right support and left support? Half of the load. Total load is WL. So half of the load has to be taken by left support, half of the load has to be taken by right support. Okay. Now if I want the bending moment now is 0 at this point, and you know that it will maximum at the center, so directly go to the center here at this point. So at this point means this is how much? L by 2. So here, now you know the convention, no? You know the convention. Anything going upwards is positive. Okay. So WL by 2 acting at a distance How much? L by 2 is positive or negative? It's positive. And then this length is how much? L by 2. What is the intensity? W. So W into L by 2, that load placed at the center. So that is WL by 2 placed at the center of this. Now what is this distance? Can you tell me now? It is L by 4. It is L by 4. So this is W L by, sorry, W, this is W L by 2. This is W L by 2 into L by 4. Okay. So this is what? W L square by 4 minus W L square by 8. So you can write this as 2 into this one. So what is the value now? W L square by 8. So you can say M max is equal to W L square by 8. So you should remember these 4 equations. I think first one is easy. M max is equal to PL. And here it is the WL square by 2. Here it is PL by 4. Here it is WL square by 8. Sometimes you may forget, but you already know how to calculate bending moment, so you can definitely do it. Okay, now with this idea, we will try to solve a numerical.